This is a demo of the SmithMatch application, a free CAD program for RF circuit design and simulation. SmithMatch consists of a component bank with all addable components in the top right corner. Below the component bank is the design space, which shows all elements in the current design. In the bottom right is a results table where all simulation frequencies are shown, along with the corresponding reflection coefficient, impedance, and return loss for the network in the design space. And circuit performance is plotted in real time on an interactive Smith chart on the left. The design space is initialized with a matched 50 ohm source and load. Load impedance is shown in red on the Smith chart and can be modified either by dragging the point on the Smith chart or by entering a new value to the load's input field in the design space. To add a component, click the desired icon in the component bank and it will be inserted as the first element in the circuit adjacent to the source. Similar to the load, component values can be modified by dragging the corresponding point on the Smith chart or by entering a new value in the design space. As additional component values are added, the impedance looking towards the load from the component is plotted on the Smith chart in green. The last component in the design space is plotted in yellow and represents the total impedance of the circuit from the perspective of the source. A component can be reordered in the circuit by clicking it in the design space and dragging it to the desired position. Default units are in picofarads and nanohenries for reactive elements, ohms for impedances, and millimeters for transmission line and stub lengths. But a component's units can be changed by clicking it in the design space and selecting a new unit from the resulting drop-down menu. The default simulation frequency is 1 GHz, but new frequencies can be added using the Add Frequency button. As in the design space, the frequency value and units can be changed using the input field and drop-down menu respectively. And the Delete button can be used to remove any unwanted component or frequency. To see how SmithMatch would be used in a practical design setting, consider an unmatched network with a 50 ohm source and 100 ohm load. At a single frequency of 1 GHz, the network can be matched using a 2-element low-pass L network. First add a shunt capacitor and adjust its capacitance until the network's impedance intersects with the constant resistance circle of 50 ohms on the Smith chart. Then add a series inductor and adjust its value until the circuit is matched at the center of the Smith chart. Matching at one frequency is simple, but the task becomes more difficult when multiple frequencies are introduced. After adding 1.1 and 1.2 GHz simulation frequencies, we can see that our 2-element L network is not sufficient to match this broader bandwidth. Regardless of the component values, we cannot match all frequencies simultaneously with this configuration. To achieve a broader band match, we can add additional stages to the network. Following the same low-pass design, with a few additional LC stages, we can achieve a much better compromise between these three frequencies. How to size each element is less intuitive when multiple frequencies are simulated, but through the interactive Smith chart and some trial and error, it is not difficult to see how adjusting each component in the design causes the network impedance to either spread apart or cluster together, creating a broadband match at 50 ohms. The live feedback and responsiveness from SmithMatch is what makes it an effective design tool and educational resource for teaching how to use a Smith chart to design RF matching networks.